Making sense of algebra. In this lesson we look at the laws of algebra, like terms, expanding brackets, and factorising. We can use algebra to write a statement involving an unknown value of a quantity. For example, if we use P for the price of a tyre, and we were quoted the price of 4 tyres and a $45 wheel balance as $485, we can write that statement 4P plus 45 equals 485. We can also use algebra to represent the relationship between two variables. For example, the temperature in degrees Fahrenheit can be found by using the conversion given by this equation. All the rules of arithmetic apply to algebra as well, so if we can do things with numbers, we can also do it with our algebraic symbols. Let's look at those laws of arithmetic that we are familiar with and apply them to algebra. Firstly, we can reverse the order when we're adding. So 6 plus 3 is the same as 3 plus 6. This works for any two numbers, so we can represent the two numbers as A and B. Then A plus B equals B plus A. This also works with multiplication. 2 times 4 is the same as 4 times 2. And it could be any two numbers, so A times B is equal to B times A. Does this apply to subtraction and division? Let's have a look. If we have 10 take away 2, does that equal 2 take away 10? And of course the answer is no. And likewise with division, that doesn't work. 4 divided by 2 does not equal 2 divided by 4. The associative law tells us that we can multiply any two of three numbers together first and still get the same result. So adding the 6 plus 3 together first and then adding the 4 will give us 13, and we get the same result if we added the 3 and the 4 together first, to which we add the 6. The three numbers can be any numbers, so we'll represent those as A, B and C, and this is telling us that we can add the first two numbers together first or the last two first. We'll still get the same result. And in fact, using the commutative law in conjunction with this, we can add the A and the C together first and then add the B. Now the same applies to multiplication. We have 2 by 4 vertical blocks. We have 3 of those, so we'll have 24 of the little blocks. On the right hand side we have 2 layers of 4 by 3 horizontal blocks. We still have 24 little blocks. This applies with any numbers A, B and C. So again we can indicate that by showing which pair we multiply together first. And again we can use the commutative law and rearrange the order there and do A times C first and then multiply that by B. Now will this apply to subtraction and division? For example, if we have 10 take away 3 and then take away 2, we'll get a different result to 10 take away 3 take away 2 first. Try it out and you'll see. And likewise with division, we'll get different results depending on which pair we do together first. When terms have the same letter parts, we refer to them as like terms. So for example, 3m and 4m are like terms. Now 3m is really 3 times m. So if we have 3 lots of m plus 4 lots of m, we have 7 lots of m. We can add those two together. However, we cannot add 3m and 4p. They are not like terms, they represent different numbers, so we don't get 7 of anything. In this example, we want to simplify that expression. So what we have to do is group the like terms together. So the x terms go together and the y terms go together. And then we can add them. So 8x minus 5x will give us 3x, and the 4y and the 2y will give us 6y. The distributive law is used to expand brackets. Now the 3 outside the brackets really means 3 times the 2 plus 4. We'll represent the 2 plus 4 as 2 blue blocks and 4 yellow blocks. We have 3 of those, and so we'll end up, of course, with 18 blocks altogether. Now we can split that up into 3 lots of blue blocks, that's 3 times 2, and 3 lots of yellow blocks, that's 3 times 4. Now of course this will work with any 3 numbers, so we can represent the 3 numbers as A, B and C. And you can see that we need to multiply the A by the B and A by the C and then add those two together. In this example, we are asked to expand that expression. We'll use the distributive law to expand that. That means that the 3c has to be multiplied by the 2c firstly, and to that we will add the 3c times the d. Now 3c really means 3 times c, to which we multiply 2 times c, and then we add the 3 times the c times the d. Not forgetting that we do the multiplication first. We'll rearrange the first 2 terms there and put the numbers together so that we can multiply 3 times 2 firstly to get 6, and the c times c to get c squared. And of course the 3 times c times d is just written as 3cd. In this next example, we have 2 brackets. Now that means we have to multiply the first term by the second bracket, and then the second term, which is a subtract 7, by the second bracket as well. Expanding these out, we have x times 2x is 2x squared, x times 3 is 3x, minus 7 times 2x is minus 14x, and minus 7 times 3 is minus 21. Notice that we can work with the 2 brackets at once as we did on the left side there, or we can split them up into 2 brackets as we did on the right hand side. Now we have 2 like terms there, the 3x and the minus 14x can be combined into a minus 11x. And that is our solution. We can use the distributive law to help us multiply 5 by 23. We'll break up the 23 into 20 plus 3, and then we have 5 lots of 20 and 5 lots of 3, so that's 115. Factorising is the reverse of expanding. So for example, if we wanted to factorise 15c minus 6, what we need to do is look for a common factor between those 2 terms. Now 15c is 3 times 5 times c, and 6 is 3 times 2. The common factor there is the 3. And so we can take the 3 out of the common factor, and that leaves us with 5c that the 3 is being multiplied by, and then subtract 2 that's also being multiplied by 3. In algebra, we represent unknown quantities with letters or pronumerals. We interpret 3m to mean 3 times m. What we can do with numbers, like rearranging the order when we're adding or multiplying, also applies to algebraic terms. Like terms refer to terms that have the same letter parts, and they can be added or subtracted together. The distributive law told us that we multiply each of the terms inside the brackets by the number outside the bracket.